Hi everyone, today we're going to learn how to graph quadratic equations from vertex form. So yesterday with Mr. Lamb, you learned how to look at a vertex form of an equation and how to name different transformations so you can look at the equation and see how it will change your graph. So if you remember, the plus or minus sign that you might see in front tells you that your graph will open upward or downward. So if you see that it's positive, your graph is going to open upward like this. And if you see that it's negative, our graph opens downward. Now what we learned for this value, this h value, is since it's grouped with your x, it tells you to move left or right. Now the little trick that we learned is that if it says minus a number, it actually moves to the right. And if it says plus a number, it actually moves to the left. So these move in the opposite direction than you would think. Now this last number at the end, this plus k, notice it's outside of the parentheses. This number will tell you how much to move up or down. So if the number is positive, we go up, and if it's negative, we go down. So since these numbers tell you how much to move left, right, and up or down, this is going to help us determine where the vertex of our graph is, and our vertex is always going to be at HK. So notice, again, this value is always going to be opposite of what you see. So if that's what this negative means, so if you see minus 2, we're actually going to put a positive 2 here. And if you see positive 3, we actually put a negative 3 here. So we're going to describe our transformations, find our vertex, and then sketch a really quick graph. And if you know where your vertex is and you know which way it opens, you should be good to go. Oh, there's one more we left out. That's that a value. So this a value tells us whether we go narrower or wider. And ignore the negatives here. So just imagine that our a value is always positive. So we're going to go narrower if a is greater than 1, and we go wider if a is less than 1, assuming that a is always going to be positive. So remember, bigger numbers make our graph grow faster, so it becomes narrower, and smaller numbers make our graphs grow slower, so it becomes wider. Okay, look at this first example. So we have y equals x minus 3 squared plus 1. So I'm going to start at the very beginning. Since I see that it's positive, since I don't see a negative, it's positive. This is how I know that my graph is going to open upward. Now I don't see an a value here, which means it's not going to get wider or narrower. It's just going to stay the same as our parent function. Now notice here, since this value says minus 3, remember if it says minus, we actually move to the right 3. Now the number at the end says plus 1, so that number is telling us to move up 1. So really quick, let's talk about why this moves our vertex. So if you remember, our parent function looks something like this. This is the parent function y equals x squared. So if I take my vertex right here and I move it to the right 3 and up 1, so I go right 3, up 1, my vertex is now here. So you can see that since I moved right 3, up 1, my vertex is at 3, 1. And then now, to finish graphing, we know, again, that our graph opens upwards, and it hasn't gotten any skinnier or wider, so it's just going to stay looking like this. So there you go. So really, if you know where your vertex is, then just make sure your graph is opening in the correct direction, and make sure you adjust for any a values if you have one. But make sure you can identify what the vertex is. Remember, it's always going to be the opposite of this number, and then this number stays the same. Okay, let's look at this one. So here, I'm always going to start in the front. Since I see that we have a negative, which is right here, I know that this makes our graph open downward. So now we have a sad face graph. The next thing we see is a 2. That's our A value. So since that A value is bigger than 1, it's going to make our graph grow really fast, so it's actually going to get skinnier and narrower. And then the last thing I see is x plus 2. Remember, anything inside parentheses will act in the opposite way that you think. So even though it says plus 2, we're actually going to move to the left 2. So those are the only changes to our graph. So imagine we start at 0, 0, which is where the vertex of our parent function is, and then we move to the left 2. That's where our vertex is now going to be. So you can see that our vertex is at -2, 0. Another way of looking at that is hk. Remember, h is always opposite, so this becomes -2, and since we don't see anything at the end, it's really a 0. So again, our vertex is at -2, 0. From here, we know that we're going to have a narrower graph that opens downward, so it's going to look something like this. And there you go. So again, we can look at each transformation. We know that it moves to the left 2. It's going to open downward, and it's a little narrower than our parent function. Okay, let's look at this next example. So here, I see that it's a positive in front. So that means that our graph is going to open upward. But then I see that I have an A value that is less than 1. My A value is 1/2, which makes our graph wider. So now in this problem, you might notice that there's no parentheses, which means our graph actually doesn't move left or right. It stays right where it is in terms of horizontal movement. But I do see a -4 at the end. So this -4 is going to move our graph down 4. So notice this number is not inside our parentheses. That's why it moves down 4. So since we are starting at the origin and we move down 4, our vertex is going to be right here at 0, -4. Remember, that's also the hk. In this case, our h is 0 and our k is -4. So then I know that our graph opens upward, and then it's going to be a little bit wider than usual, so it looks more like this. There we go. So there's a rough sketch of this parabola. Again, we usually start at the origin, but this one has moved down 4. It still opens upward, but it's a little bit wider than our parent function. Okay, let's try this last problem together. So the first thing I notice is that there's a negative out front, which means our graph is going to open downward. So remember, negative graphs give you sad face graphs. So the next thing I see is an A value that is less than 1, which means our graph is going to be wider than usual. It doesn't grow as fast. It's going to be wider. Then I see that we have x plus 1. So remember, anything inside the parentheses moves left or right, and it's actually going to move in the opposite direction, so it goes left 1, even though it says plus 1. And then anything outside the parentheses moves up or down, and this one is down 3. So if I start at the origin and I move my vertex left 1 and down 3, I can see that my vertex is going to be right here at -1, 3. And remember, it's always hk, the opposite of this number and this number exactly. Sorry, I'm missing the negative there. -1, -3. And then I look at my other transformations again. I know it's going to open downward and it's going to be a wider graph. So my graph is going to look something like this. And there you go. So again, I moved my graph left 1, down 3, and then I made it open downwards and I made it a wider graph. Okay, that is all for today's video. Thank you so much for watching.